So this is an overview of assignment 6, and the worksheet is available on GitHub. It's a project again, because now we're going to automate some analysis. Usually what we did is we translated some software artifacts, maybe some feature models or some kind of other constraints that we then wanted to solve using a formal methods tool. So this one is slightly different. Now, instead of analyzing some other kind of software artifacts, we're going to analyze some formal methods, tools, specifications. So basically, you can also see them as artifacts, and we're going to analyze some quality attributes of these. So for example, if you have an alloy module, you might wonder whether some of the signatures that you have there are dead signatures. So there is no instance that would actually have an element and an atom for that signature. No matter how you can try to find an instance, this might be something interesting to see whether signatures are dead, or similarly, you might want to analyze whether there are any core signatures. So every possible instance out of the many, many instances that Alloy could generate, all of them will have at least one element, one atom for this signature. Then we would say that signature is a core signature. So yeah, there is some description here, how you set up the project. Very, very similar to the way we previously did it. We are just going to import it into Eclipse again. So I already cloned the repository here. You can either now use it as a template repository and create your own repository, and then you can work directly with it. That's maybe the easiest. Otherwise, you could simply clone this one and work on that copy. I already have a copy of it, and now we're going to import it. It's again a Gradle project, existing Gradle project, and then we need to choose the folder of it. It found a project. That's good. Yeah, and then there are a few folders here. So there's one, source main resources. So let's have a look at maybe this example that we had many times before. I'm just going to open it in Alloy. Can open it. Yeah. Okay. So this is the list example here. Now we might wonder is, so what are the signatures? There's the list signature, the node signature. Is any of these dead? So we could, of course, browse instances. So we see, there's a node atom and the list atom. So none of them will be dead, right? Because they appear in some instances. Now, the question is, are they core signatures? We don't know. We could browse all solutions and then check, do all of them have atoms of list? Do all of them have atoms of node? But that's very, maybe not the best idea. You could try that, but there are maybe better ways to do that, to figure out whether there are instances where, let's say, no list atom exists. Then list would not be core. Simply by looking at this, we see that it's not possible because there's always one list atom, right? This one sig list means there's always one. So we will see, or this means that basically list is a core signature. Now for node, it's not that obvious. It could be that somehow nodes are required. For example, if we would have this header one node, then node would also be core because list is core, and then suddenly node is core because every list needs at least one node, right? But we have lone, so maybe node is not a core signature. So it's not trivial to see this, so we need to automate an analysis. But now let's have a look at the project. What do we have? We have again a source main Java. There's a file called alloy checker. This is where you're going to put your code for task 1, for task 2, for task 3. And then there are some examples. So these examples are not my examples. They're actually from the alloy source code, maybe some older version of alloy source code, but they still work. They are from the official repository. You can see this, the actual path, the actual class name in the repository. This project here comes with a library file which actually contains the alloy class, all the alloy classes, all the alloy code in this jar file here. So because it's a Gradle project, we automatically add this to the class path, and then we can use alloy classes like here, this A4 options. This actually belongs to the alloy implementation. We can use that in our own Java classes. So there is an example here, example using the compiler, and this has a simple main method. In the main method, we initialize some objects that are required, but the more interesting stuff, so it would iterate over the arguments that we give it in the main file, and then it would parse the current file and then try to analyze that file. The analysis, actually, there are a few steps involved. There's this execute command, which basically takes a reporter, which is always some standard reporter. We don't have to care about that. Then the world get all reachable signatures. The world is basically the object that we parsed from the file. So we're always going to get some object that we parse from a file. We can ask it for all reachable signatures. And then some command. We can also get the list of commands from the file that we parsed. So here the world came out of this file name that we parsed. There's a list of commands. And as you might see later for the tasks, we're only going to look at the first command. We're not going to check all of them. If we run this, you can, now in your IDE, you can run it as a normal, as a normal file. It's not going to do much because we didn't give it anything to work on. We didn't give it any parameters. So if we want to run it actually with a parameter, we can go to the run configurations and then give it some arguments here, which is always a bit tricky. Or we can simply say here, if we just modify this, args is a new string array, and we want to have some file name in there. So let's take the list one. The list one is somewhere here, source main resources list. So on my computer, it would be something like this. Just maybe the other kind of separators. This was source main resources list. So let's see if we tell it not to use this from the args, but actually read the list, then it's going to read the module and give an instance. So the way that it prints the instances here, this is the textual variant that we can also see if we click on text, right? So that's how it would show the instances, and this is how it would visualize them. So this is what this example code does. It reads the files that it gets in the arguments, parses everything from those files. For every single command that it has in there, in the list example, we only had a single command, right? We only had this run cyclic for 3. But for every single command, it would then try to solve for that command. check whether it's satisfiable. So is there a solution? If there is a solution, it would print an XML file and also open the visualizer as we just saw. So if we run it, some visualizer is still open. That's not the one. Let's just kill it. Okay, so if we run it again, we will see that this visualizer now popped open and it printed the instance. Where did it print the instance? Here, this line, it printed the instance. So you can have a look at this example code. And then there is another example code where actually the alloy formulas, they are created. So we usually wrote alloy formulas like that in the alloy syntax. But if you programmatically want to create formulas, then the examples are shown here in the API. So for example, here it automatically creates signatures, an abstract signature, another signature B. But yeah, we don't need this for this task. We need some other things maybe for this task, but they are outlined in the README. Okay, so that's the kind of available code that is here. And in addition, there are again test cases. So the test cases, they will then refer to the tasks. So now we could run everything without knowing what tasks we have. So let's run everything at JUnit tests, and we see most of it crashes because we didn't implement anything yet. That's the overview of the project. The main things are this example using the API, which is an official example by Alloy, example using the compiler, which also shows you how to read stuff from files, and then this Alloy checker, which we will go over in the overview of the tasks.